Hi guys, welcome back. So in this video, I'm going to be going over AMC 10B 2021 fall. I think in this video, I'm just going to do 11 and 12. So I'm trying to make like shorter videos, just going over like maybe one or two problems at a time, as opposed to like five, because it tends to be a lot and it makes the videos a little bit too long. So I think I'll try to make the videos a little shorter. I'm also trying to have better notes ready so that I can be a little bit more efficient in my videos. So this problem, number 11, says a regular hexagon of side length 1 is inscribed in a circle. Each minor arc of the circle determined by a side of the hexagon is reflected over that side. What is the area of the hexagon bounded by these 6 reflected arcs? Okay, so we have a regular hexagon, right, that's inscribed inside of a circle. Which obviously this is not going to look great, but just sort of pretend that it looks okay. Right? So, and what's happening is we're taking each of these little arcs, these red arcs, like for example, this one, right? And we're reflecting it over that side of the hexagon. So it's going to kind of go in like this, right? So it's going to kind of go like that, right? And then the same thing with this one and this one and this one and this one and this one. And what the question wants is it wants what's this sort of inside area in here, sort of in between all the little arcs, right? So it's actually not as hard as you might think. It's actually pretty easy. So what we can do is we can just look at sort of one sort of piece of the hexagon, right? We can look at just sort of like, 1/6 of it, right? Like sort of pretend, remembering that this is like just 1/6 of the whole thing, right? And then what we can do is we can say, okay, well, what's the area going to be? What would be the area if we sort of invert this? Whoops, sorry about that. What would be the area if we invert this arc, right? And like, what do we get for this sort of inner area, right? Well, one way that you can kind of think about this is to imagine taking two, like, okay, sorry. So remember, like we have this, this piece, this triangle, right? It's an equilateral triangle. And then we have this piece of the circle, right? And then imagine if we basically doubled it. So what if we reflected the triangle over its own side, right? So that we ended up having basically two of that triangle, right? And then we basically subtract the area of the piece of the circle, the sector, I think, right? The sector of the circle, right? Well, then what would we be left with? We'd be left with the area that's sort of the piece that we're looking for, the inverted area, right? Well, if we think about it, like, okay, so how much would be the area of one of those triangles? Well, the area of the triangle, so if you've taken some trig, it's 1/2, right? AB sine C, right? Which in this case, it's 1/2. Well, remember, this is an equilateral triangle because it's 1/6 of a regular hexagon. Remember, all the angles inside of a hexagon are 120 degrees, which means if we break it up into the 6 triangles, they're each going to be 60, 60, 60, 66, right? So we have a bunch of equilateral, right? All the side lengths are 1 because the radius of the circle is 1. Well, and it also said the side of the hexagon has side length 1, right? And then since each angle is 60 degrees, right? Well, sine of 60 is square root 3 over 2, right? So we have 1/2 times 1 times square root 3 over 2, or square root 3 over 4. So the area of one of the equilateral triangles is square root 3 over 4. Remember, we said, well, what happens if we double that triangle? So we flip it over itself and create sort of like a diamond shape, right? Well, then we would multiply this by 2 and we would get what? Square root 3 over 2, right? So that would be the area of this large diamond shape, right? But then remember, what we want to do is we want to subtract the area of one of these sectors of the circle. right? The sector of the circle with an angle of 60 degrees, right? That angle is 60 degrees, which means it's 1/6 of the circle. So we're subtracting 1/6 pi r squared. Remember, the radius is 1 because this distance is 1, right? So it's pi times 1 squared. So it's basically just 1/6 pi. So we're doing square root 3 over 2 minus pi over 6, right? And that's going to give us the area of this sort of orange inverted triangle thing. I don't even know what to call it. But remember, we have 6 of them because we have a hexagon, right? We're going to have an entire hexagon. So we're going to multiply by 6, right, to get the whole thing, right? So we're basically going to do this times 6, which is going to give us what? Square root 3 over 3. No, sorry. It's going to give us, whoops, 3 square root 3 minus pi over 2. No, minus pi. I'm sorry. A little early for me. I'm making some mistakes. So we get square root 3 over 3 minus pi. Whoa. Oh my God, guys. I'm so sorry about all this. It clicks on the wrong thing. 3 square root 3 minus pi, which would be choice B. So the answer for 11 is choice B, right? I thought that one really wasn't too hard, right? Okay, then number 12. Let me just move this out of the way. Number 12. Oh yeah, this one was weird. Yeah, I didn't like this problem. I don't like problems like this because problems like this require you to go through the answer choices, and I'm just not a fan of that. Like, I prefer a problem that you can sort of solve from the bottom up, like not like try each answer choice. Yeah, so this unfortunately is a problem where you'd have to go one by one and see which one works. So it's which of the following conditions is sufficient to guarantee that integers x, y, and z satisfy the equation x minus y plus y minus z plus z minus x equals 1, right? Well, if we look at choice A, it really doesn't look like choice A is giving us much to work with. It's just telling us x is bigger than y and y is equal to z. Y being equal to z basically just makes this middle part 0, right? But then all we're left with is x minus y plus z minus x is 1. And there's definitely not enough information for us to determine that that could be true or false. Like I could come up with a situation where that could be true and one where it could be false, given these conditions. So they're definitely not sufficient to say that that's true, right? So we can get rid of A. Now, what I did moving forward was I tried to solve for all the variables in terms of one variable. So if we look at letter B, right, it tells us x is y minus 1 and y is z minus 1. So maybe what I'll do is I'll get everything in terms of z, right? So if x is y, so if y is z minus 1, right, and x is y minus 1, then x must be z minus 2, right? And z is just z. And now if we substitute these values in, is it going to result in 1? The answer is no, right? So if you substitute these into the equation, you will not get 1 as your result. I could just sort of quickly do it mentally. So you get z minus 2, z minus 2, get negative 1. So you get z minus 2 times negative 1. Here, instead of like writing it all out, I'm just going to kind of like mentally see what it would come out to. So you get z minus 2 times negative 1 plus z minus 1 times z minus 1 minus z, which would be negative 1, plus z minus 2, which would be 2. So if you do that, you get negative z plus 2 minus z plus 1 plus 2z is 0 is equal to 1. But that gives you 3 equals 1, which is false. So B is false, right? So what I'll do is instead of going, and also we can, looking at E is not sufficient because again, using that condition of letter E, I can come up with situations that would make it true or false, right? It's not enough. I need more specifics in terms of X, Y, and Z in relation to each other, right? So I will tell you that C is also false, which you can easily check by yourself because you can you can do exactly what I did here. You can say x is z plus 1, y is z plus 1 plus 1, or z plus 2, z is z. And you can, by plugging in, you'll realize that it does not come out to be true. So let's just show why D is true. Let me just convince you that D is the true situation, right? So what we have is x is z, right? Y minus 1 is x, which means y is x plus 1, which means y is z plus 1, right? And then z is z. So let's plug those in. So we'll get what? Z minus z plus 1, right? So z minus 1 plus z plus 1 times z plus 1 minus z, which is just 1, plus z times z minus z, which is 0, equals 1. Z times negative 1 plus z plus 1 equals 1. This would be negative z plus 1 equals 1. 1 equals 1, true. So the answer is D, right? Again, I'm not a fan of problems like that. I don't like trial and error. I don't like trying out the answer choices. It does not make for an interesting problem, but they always show up on AMC. So it's good to kind of know how to handle problems like that. One thing, don't go too crazy trying to like work with this and trying to set it to fit with an answer choice. Problems like these are unfortunately made to try the answer choices, right? So, which is a test taking skill. So it is what it is. Okay, so in my next video, I think I'll do 13 and 14. All right, so I'll do 2 at a time. All right, hope this was helpful to you. And see you next time.